I'm very excited about today's keynote speaker. Fareed and I had talked about it at the end of last week, and he's a big believer in Dr. Reynolds. So Dr. Reynolds is involved in one of the more prominent HLT programs in the government. I'm pleased to introduce Dr. Doug Reynolds, who is a senior member of the technical staff at MIT Lincoln Laboratory. Dr. Reynolds holds more than 200 publications and is the recipient of the MIT Lincoln Laboratory Technical Excellence Award. He is currently on IPA assignment as the technical director for VISTA, the Video, Image, Speech, and Text Analytic Research Office at the National Security Agency, and is today's keynote speaker. So with that, Doug, I invite you to give your presentation.
All right, wonderful. Thank you so much, Bruce. I will pre-apologize. Doing these things from home, the neighbors we have upstairs are either doing some renovations or invited in some elephants for today. So you may hear some pounding. That's all right. So thank you very much. I appreciate being invited to speak at the HLTCon. As we said, it's a kind of a difficult new time with doing these remotely, but hopefully it'll still give people the breadth and depth that they need to take away from these. As was mentioned, I'm the technical director in the VISTA Research Office at NSA. I came in 2018 on this IPA sabbatical, sort of sabbatical assignment from MIT Lincoln Laboratory to work closely with the people in that office because I'd been working with him before as a researcher, and I really wanted to get closer to the task itself and where things are actually happening inside the government. What I want to talk about today is kind of a framework and general outline of how I've tried to form up speaking to our group and to other ones in the research about the ubiquitous role of data in the HLT deployments. And specifically today, I just have two kind of key points that I want to go through. First, I'm going to talk about the VISTA approach to deployments. So one thing I was tasked with when I first came in as a technical director, and most technical directors in offices are really focused on what I would call the technical hygiene of the office, trying to lay out the framework and ways in which people can talk about the work that they're doing and the technical aspects and strategy that we need to take. And in research, that's particularly important because people want to see how they're going to progress from their ideas to deployments, right? When people are working in an applied research environment, they really want to see things used. Academics want to see it used, but perhaps in that field, which I came from before, publishing papers is enough to get that through with your peers. But here, people want to see the thing push its all the way through from the idea to the deployment, which is not an easy path to take in that. So I'm going to speak about some frameworks we put together in VISTA to talk about moving ideas to deployment. And then secondly, I'm going to speak to the theme of today, the ubiquitous role of data, in describing the various ways that data is used throughout. I won't go into great specifics and details in this forum, but needless to say, some of these ideas won't be new, right? If you've worked in machine learning, these are important, but I think repeating them again is very important to do. You don't know how many times we get shown something that's flashy, it's got a great UI, it looks good, but when you start probing beneath it about how the underlying machine learning was trained, you often come up with crickets. And this is really what I've tried to impart to our research team, is that our goal is to get the best we can for the core analytics themselves, and then it'll move its way on to doing the UI, UX experience and other pieces. So let me start off with just one big lesson that I've learned over my time, and this should be no surprise to anybody that's worked in these developments, but it's not necessarily clear all the times in government of how this should work. One thing we know that doesn't work is throwing it over the transom. If researchers want to write their code, get to a point, and then say, well, I wrote it up, here you go, I'm going to toss it over the wall. Deployment, you take this and make heads or tails of it and figure it out. And then they get that done and they throw it over the wall and they say, okay, analyst, here you go, you got it, we're done. That is maybe would work one time. Oftentimes it's going to fail. It's going to fail at multiple points. One is deployment may have very good software engineers, but not necessarily follow the research or understand the underlying algorithms that are there. Not that they're not capable of it, just that it's not their bailiwick. And sometimes you get that when someone engineers a research thing, they say, well, this is taking too much time. I should cut this out. And it might be very important to have that in there. Or researchers can be involved to say, how can we make this better or faster? And the same goes from the analyst. If it's just thrown over the transom to them, they may get it with this really shiny UI and not have a clue as to how to use it, or have the feedback of this is just overwhelming to me, or how do I tell you I want it improved? So this stovepipe, throw it over the transom type thing is just never really worked out. What has worked, of course, as you imagine, is just a continuum of going from the research to deployment to the analysts. And then more importantly, with that feedback. And what I mean by this continuum is that there's a blurry line between research and deployment. And it reaches all the way over to the analyst side of things, where we want to know how it's working and get the feedback so we can improve the underlying algorithms and analytics that we've put together. And this is one thing that we have done very well, I believe, in the VISTA Research Office, working with our counterparts, is moving those, is trying to have more of an integrated flow between the research deployment and the analysts. And one way we do this to execute from the research side is what I've dubbed, and it's been dubbed before, is called the virtuous cycle. Where this starts off is with mission in the middle, right? It's the center of everything. What is the mission problem? We're an applied research organization. We're here to try to solve things that are going to help mission be accomplished, in our case at NSA, in the IC. So what we'll do is work with the analysts on the mission side to understand where the pain points are, where there's places that we might be able to come together and help them. We'll then translate that into what I call a challenge problem, which is basically recasting the mission need as a research challenge. If someone is saying in mission, I'm going through and reading lots of text and I can't get through it all, you might turn that into, well, is there ways to search for the information you want? Keyword search, topic, and so forth. How can we turn that into a research challenge? Then once we have it turned into a research challenge, we can move it to the first phase of the unclassified research and development. And this is where we identify and collect relevant proxy data sets, sponsor evaluations, so that we can leverage the worldwide research community. In VISTA, we've done this for examples in evaluations that we've co-sponsored with the National Institutes of Standards and Technology, NIST, in doing speaker recognition evaluations, language recognition evaluations, and other types of HLT evaluations. And the beauty on this, as I'll get to later, is it applies the framework where it brings people in that they can work. A lot of the people in the research community working in machine learning and AI want to work on the algorithms themselves, but they're missing the scaffolding around it, or the scaffolding around that research they want to conduct isn't set up and takes some time and effort to do. And I'll describe that scaffolding later on that enables us to leverage this worldwide research community to work on problems of interest by having the relevant proxy data. Once something's proven itself out, it looks like it's promising, it's being picked up and validated through various labs, then we'll go into the classified research and development. And this is where we move this inside. We'll identify and annotate relevant classified data sets, take those techniques and algorithms that have proven themselves out on our unclassified evaluations and research, bring them in and tune and adapt and evaluate the promising approaches, but now using operational data that's relevant to us. Again, once that's past a certain threshold, there's no real hard threshold in this, but it's holding up, it looks like it's doing well, it's getting our internal peer review on it, that it looks so solid. Then we may move to the prototype stage, where we will take and test the analytics on a larger set of mission data, because oftentimes the first set of data you used in the classified research and development environment may have been a bit static, right? You have to get the data, curate it, and annotate it. That may not represent the wide range that you may see if you turn it on to open the aperture on the mission data itself. And furthermore, we'll get some feedback from the analysts in their workflow. So they can run this, they can see what's happening, get an idea that, yeah, it looks like it's promising in that. And then that'll give us the impetus to move forward to the deployment, the hardening up, where we have to engineer, instrument, and harden the analytics for, in some cases, enterprise deployment. So getting it ready to go and all the engineering aspects that go along with that, and some modifications and other things that may have to take place for speed and performance once it's opened up into the enterprise system. But that's not where we ended. As I said, this is not just a single one-way street. We also then want to incorporate feedback from mission use to improve the analytic and spawn off new challenges. So the spawning off challenges may be it's not working in some languages or domains, and that may spin off another challenge that we want to work on. But more importantly here, as I'll talk to you later on, the ubiquitous role of data is getting feedback from the users as they use the system itself to help improve the underlying model and keep this going up and not a single static push out and done. And as I already mentioned before, effective execution requires a team effort between the research deployment and the user communities, as I showed with that continuum. That's not just a one-way, not with walls between it, but a continuous passing of the information through the different layers with the feedback into the research and development. So one of the things we do when we're looking at working on some type of analytic or new thing we want to research on or that we want to develop is an analytic assessment that we'll ask ourselves here. And one of them, as I mentioned already, with mission first is going to be, what's the mission use case? Where's it going to be used? What problem is it solving there? Is there a user champion? Is there someone on the user side that's going to help you pull this through? We don't want to develop things that are shiny objects that look cool to us if it's no one there that's going to take it. Doesn't always mean they know exactly what they want. So we're not here to build a faster horse when we ask them, what do you want, instead of a car. But we do want someone that's going to be there to try it out when we do build the car versus just building it and having crickets. How is it currently being done? So we really want to do the trade-off. Sometimes you can come up and get enamored with some AI ML solution that's really not solving any problem. It looks neat, but it can be done the way it's currently being done or in a much simpler manner. And how, if successful, how widespread will the impact have? How many analysts or amount of data or impact is it going to have in mission? So we want to understand that. That's not always clear how we get that. Inside the government, when you're working with some of these applications, unlike in commercial applications, you can't always assign a dollar sign value, right? You have a great metric in the commercial side. How many did I sell? What's the revenue? Here, you can get very small things that actually have a huge impact because of life and safety that come into play. And very important, as we'll talk about later, is are there annotated data and resources available? Is someone willing to put skin in the game and to give us this data and help us annotate it? And that's where the user champion gets to be pretty important to have, because we're going to need them to help us do that. We can't do that all alone. And the last piece I won't go into much. It's does it fit into our VISTA portfolio of new analytic, expanding existing analytic, anticipating where analytics have changed, and exploring broader areas across modalities, such as going across the video, image, speech, and text types of modalities, or cross analytics, merging together speech recognition and OCR or something like that. So I mentioned before about this scaffolding or framework that researchers want to have before they really go to town on doing going to town on their research in a new analytic. And this isn't just idiosyncratic to the VISTA Research Office. I'd say this in general is the things that are required. They want to work here. That's where the magic happens. That's often what you see. But to get there, to give this cocoon in which this work can be done, there's 3 core components that are required. The first one is we have to be pretty clear on the task. What is it you want to do? And I think, as Bruce alluded to in the intro, this runs a gamut. Right, there's some tasks that are pretty easy to define what you want to do. Speaker recognition. Audio comes in, that's from someone speaking. I want to determine, is it a speaker I know? Face recognition. If face is detected, I send it in. Is it a face? So it's pretty clear. Event detection. Sounds good. What's an event? How do you define the event? What does it mean to be an event? So some of these things, and what are you handing in to determine that event? So some of these sound pretty straightforward to do, but you've got to really think about what's going in and what do I expect to come out. So what task am I solving? Otherwise, it can start to get very muddied when you go off to do the research. A metric. How are you going to determine how well you're doing? I already said what I wanted to do. What's my metric that's giving me some way to measure how well I'm doing that? Metrics take on various flavors. Researchers typically like metrics that are focused on being reproducible and automatic, something where we can turn the crank and run it and have a script that will give us our score out, and we can see if we're climbing the hill and making that better. You see this all the time in published papers. Some things may not allow that, or it may be more difficult to have an automatic script, automatic scoring metric. For example, you may need something more about measures of effectiveness versus measures of performance. How well did it help a person do a task? So sometimes you actually have to get a human in the loop on measuring the output of the analytic. And as I said, that can be difficult if necessary, and particularly during the research phase where we want to iterate and improve the analytics. We have to think pretty hard about the metric, especially as the tasks get more and more abstract and involve humans more closely. And lastly, but probably most importantly, is the data itself. That's going to underpin all aspects of the research you do on the analytic. What data are you going to use to do the task you want to work on, to learn the machine learning parameters, to evaluate the performance? And this can make or break the research. If you start working on data that's just not matching what you're going to see operationally or is not a good proxy, you may come up with a wonderful solution that has no hope of working at all once you open it up. And as we talked in the virtuous cycle, and I'll describe momentarily, there's waypoints that we use to determine, to help try to catch cases like this, where something looks like it's working really good on data. You see a demo that things look great, and then you go to try it and it just doesn't hold up. And that's generally because there's some problem in the data itself. So to help determine a framework and a language that we could talk about moving an analytic through the different virtuous cycle, we've laid out in the VISTA group what we call waypoints. So we can talk about an analytic being in a certain waypoint as it progresses through, and have you gone through this other waypoint? And as you'll see, these waypoints are very much data-driven waypoints. And by that, I mean, we start off with our analytic assessment. What is it we want to do? And I went through some of the questions that we ask on that, and that may be asking those about mission and doing an assessment of what's there, what currently exists, what do we need, is it new, is it something we need to invent, adapt, or adopt? Then we get into waypoint 1, which is unclassified data experiments and evaluations. So this is where we're going to do that first pass on it. We've determined what we're going to work on. We believe it has a mission need. And then we're going to do this work on proxy data that we believe reflects the operational data. And that's pretty important to do. So you don't want to work on speech recognition using clean laboratory environment speech if you expect to use this on noisy conversational speech, right? Because something will look good and during waypoint 1 and then fall apart when we go to waypoint 2, which is where we will evaluate it on classified data, relevant labeled classified data in the appropriate spaces. We'll do the experiments and evaluations on that. And again, that now requires us to have the classified data available with the annotations, because we have to have the truth marks to know that we've actually solved the task using our metric. When things look like they work through that, we'll go to the waypoint 3, and this is the operation validation on a wider variety of data. Again, opening up that aperture to try to find cases that we may not have caught or dealt with during our curated classified data evaluations before. Setting up some type of prototype implementation to allow getting feedback from the analysts, let them kind of kick the tires and play with it, versus us having the output that goes into a PowerPoint file, maybe in the waypoint 1 and 2, where we show the performance improving over our experiments. Now we want to actually put something in front of an analyst, put something in front of a user. Once we've gotten the pull on that and cycles work out, we'll do a development assessment. Is it time to move that into waypoint 4, which is a beta deployment and engineering for the enterprise operational platform? So this is where we take it inside. We've decided it's worth it, working in conjunction with our deployment team and saying they have the cycles, because their research and deployment don't necessarily run at the same rate of things, and putting it in there and doing the hardening, as I mentioned before. And then we, of course, go into waypoint 4 plus, which is once it's out there and running, it's in production mode now. We want to have things instrumented so we can get analyst feedback and truth marking. And I really can't emphasize this enough. One thing we found in our lessons, and this harkens back to the second slide, the slide I had at the beginning, is that feedback from the analyst to the research. We found it incredibly important to have instrumentation inside any tool that we put out so that it makes it easier for analysts to correct the output of our analytic as they're using it in their workflow. If you ask them to leave their current workflow, go to another tool, and help you do truth marking, you'll get some people that'll do it, but most won't. They have their job to do and they're doing it. Whereas if it's a check mark that they can just say, yeah, I'm doing my job. Yeah, you got it wrong. X, you got it right. Check. That's not correct. That's not it. I'm going to change it. Make it easy, make it straightforward, so that they can just do it while they're doing their normal job. Let me switch gears now to the latter part of talking about the ubiquitous role of data. So one thing you've seen throughout in this, we're informing up our waypoints and moving an analytic from an idea to deployment, is that data and annotations are fundamental at all those stages. Sometimes it's annotated data, sometimes it's just opening up the aperture of the data. It's unclassified, it's classified, but it's there, right? It's really going to be the thing that tells us we've really clicked through the different waypoints. It's moving along, it's actually progressing. And as I mentioned at the beginning, some of the things I'm going to talk about, the data and annotations, should be bread and butter for people, and repeating it is not meant to be condescending about things, but I think repetition is always a good way to build it in, and some questions that could be asked when you're looking at a new analytic or wanting to develop one yourself. The why, how, and where. Why are they necessary? How are they used? And where to get them? And I won't have any prescriptive ideas here. These are going to be my general views that I've seen over time, but I think they're pretty good framework, again, to talk about the data and annotations for the various stages in moving it through research to deployment. So why are data and annotations necessary? Well, again, one could say this is pretty self-evident, and let's just move on. But as I mentioned before, it's good to keep very pounding on this. The data is going to ultimately, the data used is ultimately going to determine the usability of the analytic that's produced. That's really going to be the bottom line. The analytic, the algorithms and all those matter, obviously, because deep learning has moved things along. But deep learning success was because of a new algorithmic change or add to, really, or picking up on things that had been developed before. But really, it was the amount of data that it was able to consume and use has been the big driver in there. And most of it to date is actually annotated data. It's moving away from that, but and I'll talk a little bit about that in the next of how the data is used. But it's still, annotation is the key thing for at least the evaluation portion of any analytic development. One of the key issues, as I've alluded to before, is domain mismatch. Is one of the big gotchas in doing development in the laboratory or taking an idea that's published in papers and trying to move it along. And it's one of the biggest causes of performance gap between development and deployment results. And this is why we had those waypoints, why we went through trying to look at unclassified but relevant proxy data, meaning we pay attention to what the data is and the characteristics it has to make sure it's not too far off from what we expect. And we move it into that waypoint 2, where we evaluate it on the operational classified data sets to make sure that we haven't chosen the wrong data sets, or we fooled ourselves, or there's something that has a mismatch that we haven't dealt with. Because at that point, we have time to address it. We can do things like tuning and adaptation, as I'll talk about in the next slide. Identifying relevant data to use for the training and the development is key, as I mentioned. That's going to be the thing that drives it. And one thing we've seen over time is that more data is not always the answer. More of the wrong data isn't going to help you. The right data is. And what is wrong and right? Well, I'll know it when I see it, type thing. It's really doing that, trying to gather more data. Now, where more oftentimes people talk about more data is better is because the thought is that if you have a wide aperture and you just collect more and more data, chances are you will capture some variability in there that represents what you have. That may or may not be true, or it may be a theoretical limit. So it's something to keep in mind that more may or may not be better depending on the task that you're working on. It's essential to use or at least have samples of the operational data. You may not be able to have enough labeled data or operational data to train your core analytic, but you should have enough to do evaluation on it. If you don't know how well it's working on the operational data, you're pretty much doing faith-based research and development, and that doesn't get you too far in there. You want something that tells you how well you're doing so you don't get a surprise later on. And consistent annotations are also important. That can be an issue, especially as you get to things like that are more ambiguous, like tasks. The tasks like event detection. You have to have pretty consistent annotation guidelines if you want to have multiple annotators giving you out something that can be merged together and used. And then annotated operational data allows the tracking. I already talked about evaluating, make sure it holds up. But more importantly, this notion of instrumenting the system once it's deployed to allow feedback or truth marks from the analysts themselves allows us to maybe do some early detection of data drift. And we can then do model course correction. So if we get some idea that things are performing poorly, that may come from just analysts saying, hey, this isn't working as well, although typically they just stop using it. But more importantly, we're hoping that we get the truth marks on it, and then we can start evaluating and say, hey, yeah, it's drifting. We have to do a refresh. Or maybe we do continual refreshes to make sure that the model is always up to date if we get enough of the truth marks coming in from the users. How is the data and annotation used? Well, the primary use is for, of course, what you'd expect, the model training and testing. But the expectations on the amount and quality of the annotations are going to widely differ depending on how the data is used, meaning from the training, testing, and tuning or adaptation. So for example, in training data, it could be a mix of finely annotated, coarsely annotated, or unannotated data. Finely annotated, I just mean is that it's pretty strict. It's following some very tight guidelines. It's maybe gone through Q&A. Coarsely, maybe someone just, getting feedback from analysts while they go through. Maybe it's not QA'd at the end, but it's in general just kind of in the right ballpark. And then, of course, unannotated is having no labels on it at all. Now, recently in the research community, or maybe not so recently at deep learning speeds, there's been large strides in many areas of HLT using unannotated data to build base models and then applying transfer learning. So there's a lot of hope here. There's a lot of actually some use cases that we've found where this has been really a bit of a game changer of allowing us to use some large amounts of unannotated data to build up some base model. Maybe it's not the final task. And then we can fine tune that using some annotated data, but not as much as we would have required before to tune and track that or do transfer learning to move it to the task that we want to work on. We still have to pay attention to the domain mismatch though. Training it on a large amount of unannotated data that has no relevance to how we're going to use it may look good on the outside for some experiments, but then may fall apart when we move it inside. And so that's still something to pay attention to, but with unannotated data, it's easier to go back and retry different things. The test data requires a different level of precision. We do want that to be finely annotated so we can measure performance accurately. Having loosely annotated data on the test set isn't going to do you too well because you may start driving you the wrong direction, right? You get a system that gets better and it actually is telling you the right thing, but your annotation truth mark is off or wonky and it looks like it's got an error. So you might start to discount it, especially if you start automating your testing type of model development. So that one does require a bit more of a tight scope on the annotations that are produced for it. And then lastly, there's the tuning and adaptation. I alluded a bit to this in the training about moving an unannotated model and tuning it up on the domain that we care about. So it can happen there. Now, the nice part on working with tuning or adaptation data is that coarsely annotated data, particularly from the users, like putting it in their normal workflow, can help to continuously improve the models over time. And as I said, it doesn't have to be tightly annotated. We're not evaluating on this per se. We may take some in QA it for evaluation purposes, but for some tuning aspects, we can take some indirect signals, some course labeling that they did just on the flow as they were going through from multiple people, or crowdsourcing, if you will, to allow us to tune and adapt a model and make it a little better over time. And lastly, I'll speak on where to get the data in annotation. And the way I think about the data itself is a kind of a cheeky three-way here: faked, found, and for real. So the fake data, not to diminish its value in there, it's just it's the one that came up with F on it, is we design a collection to simulate the type of operational data that's expected. So for example, we may pay people to make phone calls to collect conversational speech. And we've done this with the Linguistic Data Consortium. So there's no data that exists like this. We don't want to necessarily find it. So we can go through and say, hey, we're going to set this up, we're going to simulate it, we're going to have the right contours of how we want the data to be collected that looks like what we care about, or has flavors to it, or some signal characteristics to that. And we can then go and pay to have that data collected. We could also simulate relevant data, meaning actually create it out of whole cloth or simulate it, if we know enough to actually do that. There's some domains where maybe we do. Most domains in HLT, I would say that we don't know enough about the underlying mechanisms to simulate fidelity data that can be used for evaluations or training. It's getting better over time. There's things like data augmentation that helps take one data set and shake it up a bit so that it helps the model train. But in actually simulating relevant data for evaluations has not been had a strong track record in the HLT, in my opinion. Then there's the found data. This is where you collect public proxy data that behaves like the data you care about. For example, people do a lot on Twitter and Reddit. So you find some public data where humans are communicating, right? You're not paying them to do it. It's not fake in the sense that it's one person just doing monologues or typing to themselves. It's actual communication. So if that looks like a good proxy, you can go and collect those. And these some of these allow it. There's scraping of the web for different types of human communications that make sense. NLP has done that. Machine translations benefited a lot from doing scraping of the web to get parallel corpus for training. And then, of course, there's the for real data. And this is really the touchstone that you're going to want a piece of at one stage in the development and deployment process, where you use the operational data itself. Sometimes that can come with significant constraints and annotation costs on it. Working with operational data, not that the data is hard to get, but there's handling issues with it, and annotations just go up because now you have to do it in special spaces and cleared people for doing it. In terms of the annotation, again, there's three core ways of getting these. You can buy data annotations. So that can be where it comes along with the found data. You can crowdsource this. If you get some found data, for example, Twitter, Reddit, and maybe you can define the labeling you want and put it onto Mechanical Turk and get the truth marking back on that. If you do pay people to collect the data, it might come along for free, right? You already have it. You paid people to make the phone calls. You know who they are, so you get the ground truth as you're collecting the data. You can create your own. So that's just taking a data set and labeling it, and primarily thinking here on the classified or the operational data, which is what you're probably going to have to do there unless you have some other side signals that help you with it. And then the last piece that I've been talking about is instrumenting the workflow. So this is annotations that come in the phase 4, waypoint 4+, where we do have something out there. Now we want to instrument the workflow to allow the users to correct or annotate. And this is most useful for refining a deployed model, as I mentioned. So let me just wrap up with kind of the points that I was trying to make here. I believe the mission-centric, evaluation-driven research and development model, what we've called the virtuous cycle, has proven successful for several VISTA technology transfers. And I've seen this work throughout time. What I was trying to do when I came in, and we did before, I came in, but trying to codify this down into this is the method that we use, and people can talk about where they are. To that end, we've defined the Waypoints as a guide for tracking and talking about research progress as it moves from idea deployment, so that it's not just I'm working on an analytic or I think it works. We can now talk about where you are, what waypoints you've passed, and what needs to be done to get to the next one. And of course, underpinning all this are the data and annotations, which are fundamental to all the phases in here from, once we've assessed that we want to work on some analytic, understanding what the literature means, what data was used to get the numbers in the literature. When we see demos of some products that are out there, understanding what it was trained on, what it's working on, getting operational data annotated so we can actually evaluate it on some data inside that we know we're going to deploy it on, so we can get a sense of this is holding up, it looks impressive, or I need to do some tuning and an adaptation on that. So with that, I will wrap up. I think that gives us now about some minutes for questions and answering if there are any. So thank
6
you
minutes.
again very much.
Yep. Doug, thank you so much. Appreciate that talk. Very interesting. The questions have started to come in and I'm prioritizing. To the audience, there's a question box in the dialogue for GoToWebinar. Please insert questions into there that you'd like to ask of Doug. I've already got a few that I prioritized, and I'll continue to look at that box for additional questions and kind of prioritize in real time. So the vast majority of questions, Doug, deal with the data, right? So you've got the enviable or unenviable task, given your perspective of dealing with a lot of different data types. Do you have any recommendations, and what has your experience been with synthesizing data, and then any kind of annotation or annotation guide practices that might sit on top of that? Thoughts?
Right. So as I mentioned about the synthesizing data, I've seen that be useful when you want to do data augmentation for training the models. What I've seen with our researchers and other ones is that when you take in some data set and you want to synthetically modify it in ways that look realistic to help augment the data, that does make more robust models. That's worked out in academia. We've seen that in different times. Where it's not useful is for the evaluation side. We just can't simulate it well enough. I've been through many times where I'm primarily a speech guy, and I've seen with speech where they'll add synthetic white noise to a signal and say, hey, it's working well at 10 dB and 20 dB SNRs. It's okay. That's fine for a sniff test. It doesn't really hold up. You have to do the dirty work and get the annotated data itself to know how well it's working. But it does work for training, augmenting on there.
So kind of as a general best practice, the better annotated data, if you're data constrained, is left for the evaluation side of it to be the score versus the training side of it.
Right. So we typically, when we get a data set and we're talking about what to do, we'll start from the end backwards. We actually will start with saying, let's annotate a set that we're going to use for evaluation, or how much do we need to carve off for doing evaluation. Get that annotated because it's going to require the more finely grained annotation on top of that. Then we'll go to what's needed for training, and that can be done in a coarser manner, so we don't have to spend as much on top of that. So the annotation guidelines, I think you mentioned that before, we try to apply those when we need the finely annotated data sets on it. We used to have that more when we were getting a lot of annotated data on training data on that, and that was needed primarily because of just keeping it consistent. So there's fine grain in terms of making it right, which you want, and then there's consistency. It can be right, but people use different ways of marking the data, and that just creates a nightmare for data cleaning.
Yeah. I often refer to Basis as a data company with a software problem, and probably one of our most I don't know, important intellectual property pieces is our annotation guide, for just that reason, because it's always entertaining to sit in a room, throw out a couple examples, and hear every different kind of entity type associated with things.
Absolutely.
So
and as you pointed out, it gets more difficult the more abstract the task gets. And that's, we're moving into that. Some of the low-hanging fruit's been done. It's not over, but it's close. And then you get into events and entities, and it suddenly gets extremely important at that time to have consistent.
Entities are easy compared to the event side of the equation. So the other piece that we've gotten a lot of questions on is your involving the end users, the human in the loop, really having to get the application developers involved to update their UIs in order to give you the feedback to your models. Can you speak a little bit about that and where that's gone? Because everybody has the goal of human in the loop, but I think a lot of times the practical implementation of that is very challenging for people.
Yeah. So we were fortunate in that sense. Broadly speaking, let me break it down the way we have our system set up. There's one piece of it that is the analytic engine. It runs the analytics, right? Gets the data, runs the analytic databases, it indexes it, right? All the stuff you'd expect, right? And that's one piece. What we found we had to do, and we make that available to other places in the enterprise through APIs. But what we found is none of them had this feedback. So we ended up having to do our own user interface in there so that we could instrument it right into it. And I think you're right. Asking people to retrofit it versus build it in from the get-go is a much bigger lift. Going to someone that owns a UI and saying, hey, can you instrument this, can be difficult for two reasons. One, they have to change the UI. Maybe that's a big deal, maybe it's not. More importantly, though, the plumbing has to be in place. Once it gets labeled, where does it go? How does it get moved along? So we were fortunate in the VISTA family, I would say, that we have, that we had that piece and another one that would collect the truth marks and do something with them. But we had to consciously build that in ahead of time.
Yeah, it's quite the struggle. One of our mission partners exploits Arabic, and that's one of the language we invest heavily in. So we've got deep neural network models. We've got a lot of other capabilities surrounding it. Part of kind of our secret sauce is we give back a confidence factor on the extraction. And we'd worked with that partner to instrument the individual panels with just simple green light, yellow light, red light based on the confidence marking. And when I went on site and started talking to the analyst and was all pumped up about telling them all the advanced capabilities and they're like, oh my God, we love the lights. When did you put the lights in? Those are the best thing in the world. So it's astonishing just by giving a little bit of feedback into the end users. So it gives them perspective on how confident the system is, gives them a lot more confidence in that.
Well, and I would point out too that as you said, giving them the feedback, they do want to know it, right? Versus this black box, like you gave me this answer, what is it? And confidence can help, like say, okay, you weren't that sure, right? Getting that. The other piece is simplicity. To quote Fareed, who's I will abuse since he's in the audience and muted, 2 clicks is 1 click too many, right? I picked that up from him. You go through and you suddenly, and this goes to the annotation. If you ask 2 clicks, no, I have no time. 1 click, sure. So simplicity, feedback and simplicity seem to be the hallmarks that we really want to try to keep driving forward in the UI for the user.
Fantastic. So we're running out of time. One quick question. There seems to be a lot of questions around using coarse grained data for the training side of the model. How's that hold up against finely annotated or well annotated evaluation data? Any perspective or thoughts on that?
Well, I think it comes down to it's a question of the volume. So the finely grained on the eval data we want because we're going to compare the output of the system to the ground truth. And if we have coarsely labeled ground truth, we may start to go in the wrong direction, think it's not working well. That's not 100% true, right? You can use coarsely grained data for evaluation if you have to, but we tend to want to have that cleaner so we can do our evaluation hill climb the right way. In terms of the training side, it's primarily a matter of volume. If I can get a lot more volume and variety of data, but coarsely labeled versus small set that's gone through Q&A 5 times, with the new deep learning, we found you do better, is give me more volume and variety with coarse labels than this small, well done little set that may not have the variety we want in it.
Great, fine. Thank you, Doug, very much. Very enlightening, very interesting. You guys are doing great work over there. Fareed sends his regards. Thank you very much for your time today. Thanks, Doug.
Well, thanks, everybody. Appreciate it.